Thank you, Steve, and thanks very much to the organisers for the invitation. What struck me this morning is the amount of passion in the room. It started very early with Sadiq and his stories of years ago in agronomy, and through to all of the wonderful stories we've heard about the products that are coming along the line. I should probably admit that I've spent most of my career working on canola and not on pulses. And I should introduce my colleague Tony Swan, who's here, who is probably the pulse expert in our team, and my other colleagues from CSIRO, who spent a couple of days with. I've spent a couple of days with and hearing about their work on pulses in the West as well. So that's been good background for me. And so you see, I've got some co-authors there: Tony, Mark Peoples, who many of you would know has worked on legumes for a long time, and James Hunt. The picture shows my laboratory, and most of the data I'll show you today comes from large multi-season, multi-location field experiments, which is what I was asked to address. I'll just briefly show you that it's a huge team. I'll show you some work initially from the past, and then currently involved in a large GRDC funded project with a big team of department people. You'll see we always have consultants in our team and growers to give us that reality, and a few of the key people who've assisted me with this talk. I've got a few take-home messages because this is an after-lunch seminar and some of you might be feeling a little sleepy, so if you just, I'll quickly tell you what I'm going to tell you before I tell you. I come from an area in southern New South Wales that is completely dominated by canola wheat systems, and we've heard this morning that much of Australia is, but in our area, you know, often the cropping phase is really bumps around 2% to 4% pulse if it really gets high. So we come from that same sort of issue, and I can tell you I'm working with people in northern Germany. We've been to visit the Canadians, and around the world this is an issue. People are looking for ways to improve the amount of pulse in their system. So I have that in common with Western Australia. And the take-home message from the work we've been doing, we've been comparing what the growers and consultants consider to be their baseline system, which is a canola wheat barley, canola wheat, that kind of system, with very few legumes, with those where we've inserted different types of legumes. And most of the results tell us that you can find systems that are more profitable. They'll often be less risky. They help to keep weeds and diseases declining, or at least not increasing. And when we look at things in the longer term with simulation modelling, they also hold up in the longer term in terms of risk and so forth. I've been asked to touch on some environmental outcomes, so I've done that mostly from the literature. But of course, we've already heard this morning that there are barriers, and one of those was marketing, and I think it was you know, great to see that kick off the conference, because it is the big issue. But I think farmers are pretty rational, and when there's a profitable, reliable, marketable product, they will grow it, and pulses are no different. So lupins in WA in the 90s, lentils in South Australia in the 2000s, and chickpeas still in northern New South Wales. I mean, there's nothing essentially difficult about them when they have a fit, when they have a market, and when they can be grown and fitted into the system. So I guess we need to understand that first. So Mark Seymour said to me, well, you know, maybe you should start thinking about what's wrong with what we're doing now. And I guess the challenge for us from a farming systems point of view is that, you know, we're living off our grandfather's pasture nitrogen often. And you can see here the red is how much nitrogen we're taking off in grain in Australia. And the blue is how fertiliser has had to lift to sort of balance out effectively what is a loss of legume nitrogen, either from pastures or to a lesser extent pulses. And so we've got two options going forward, because you've all seen the food demand, the population increase. We're going to have to keep producing more food. So we either have to find more fertiliser or use it more effectively, or be more efficient with it, or get more legumes into the system, and that's our challenge. And so we focus quite a bit with legumes on nitrogen, but there are a whole lot of other ways in which legumes influence our farming system. And I've listed them there, and I just wanted to go through a few of those, just so that we aren't totally focused on the nitrogen story. So yes, this is the process I guess we're all trying to capture with legumes, nitrogen fixation by rhizobia. We know that A healthy legume can fix about 20 kilos of N per tonne of above ground biomass when it's growing well, and there can almost be as much as that underground as well, which people have started measuring recently. So it's quite a significant input of nitrogen when you think that Australian farmers on average put 45 kilos of nitrogen on their wheat crops. That's the average total nitrogen fertiliser. So it's significant. And what we hope for then is that nitrogen, not only do we grow a healthy and profitable legume for sale, but that we get benefits through into the system. But if you look at how much nitrogen is actually fixed by commercial legume crops, now this is data from Eastern Australia, but I'm sure the same would be here. There's an enormous variability in how much they fix because they have to have a good nodulation. They have to be grown healthily if you really want them to do that job. It's not just a matter of scratching in a legume and magically it produces nitrogen. So the average range, you can see, the average was 65%. So that means 65% of the nitrogen the legume has got in it has come from the atmosphere, not from the soil. So that was the average, but the range was from nearly nothing, 8, up to almost complete, 98. The average amount of nitrogen that was fixed, therefore, was about 90 kilos, but again, it can be 12 or 300. And there were 20%, so a fifth of paddocks were sort of fixing less than 50% of their nitrogen from the atmosphere. So yes, they can be profitable, they can fix a lot of nitrogen, but they won't always, and that's about good agronomy. And it's largely because either there's something restricting the legume in its growth, and that can be anything from a subsoil constraint, drought, herbicide residues, low phosphorus, anything holding the legume back, but also things holding the rhizobium back, like acid soils, high mineral nitrogen in the soil. So the legume has to be grown well, it has to be grown in the right position in the rotation, and then followed with things that can capitalise on the benefits. And if you look at how much nitrogen, this is a sort of summary table from one of Mark Peoples' reviews, and what it's got there is just the sort of average kilograms per hectare of nitrogen that can be fixed by grain pulses, brown manure pulses or pastures. They can all fix around about the same amount, 150 kilos of N with a fairly similar range around that. But of course with a pulse you're taking away the grain, you're taking away a lot of that nitrogen in the harvested grain, and so you can in fact have pulses that are mining the nitrogen and actually using nitrogen, not leaving you with nitrogen. And again, that's about growing it well and making sure it's fixing to the best of its capacity. And if you look at then how much extra mineral nitrogen do you find in the soil after a pulse compared to, say, canola or wheat, it's often measured in the soil as mineral nitrogen. It's often of this kind of order. There's a similar range around all the different legumes. Of course, if you leave it as a brown manure, you're going to leave a lot more of that nitrogen there. But that's the kind of magnitude of the nitrogen benefit. I guess we're in the home of weed management here, ARI and Weed Smart. Just moving on to now weeds away from nitrogen. And Weed Smart talk about the big 6 things you need to do to stay on top of weeds, and particularly herbicide-resistant weeds. And they're all listed there, and you can see this on their great website. And if you go through those big 6, there are at least 3 of them that relate to increasing the diversity of both crops and practices in your system. And so in terms of rotating crops and pastures, of course, adding a legume in there gives you an opportunity to do that. And particularly this idea of a double break. So 2 years out of cereal is really necessary to get on top of some difficult weed problems. And the legume canola, double break is a really good option there. Obviously using mixing and rotating herbicides is easier if you've got different crops in the rotation. And stopping weed seed set, again, you can do hay cuts or brown manures with legumes as an option, or you can spray top over the top of crops while they're maturing. So adding diversity into your system with a pulse gives you an opportunity to add to your weed management sort of arsenal. And here's some data from an experiments that Tony is writing up at the moment. And here we went into a paddock that had 1,815 ryegrass plants per square metre, so completely, almost sort of uncroppable because of ryegrass infestation. And the question was, can we buy our way out of this, or do we have to manage our way out of this, and how important is diversity and break crops in doing that? And so what I've got there is a a whole range of systems, continuous wheat, so continuing to do what was being done, and that's that top line there. And what you can see is pretty cheap on the herbicides, low cost, but also low profit, and we ended up with even more weeds than we started. So that's unsustainable. That's not going to work. What about if we go in, below that is the aggressive wheat, so go in with more expensive pre-emergent herbicides, higher wheat density, more nitrogen, and sure, you can see that we can increase our profit a little. We've got our weeds down, certainly, but it's cost us a lot. So the profit to cost ratio is down. Sticking canola in, of course, which is what most people are doing now. Things continue to improve, more profit, but more cost as well. The profit cost ratio, so that's a measure of risk, if you like, is improved. We've got the weeds down. But this option here, the double break with lupin, canola and then wheat, the lupin providing a bit of nitrogen and water into the canola, the double break allowing you to get on top of weeds. You can see we've got a nice balance, an enormous improvement in profit to cost ratio. We've got the weeds down to the lowest of any of the treatments, and we still have made a reasonable profit. So a really good compromise by introducing diversity into that system. We repeated that in a fully phased rotation with, again, comparing here just 3 systems that we called conservative, aggressive and diverse, still sticking with the old canola wheat, which is the baseline in our area, as I said. And again, just more of the same, takes your herbicide-resistant weed problem from the thousands per square metre to the 4,000, so we couldn't keep doing that. An aggressive strategy using Roundup-ready canola, higher wheat density, higher nitrogen fertilisers, more expensive pre-emergent herbicides did improve the weed issue, but you had to spend a lot more money for a little bit more profit, and so your profit to cost ratio was down. And again, the most well-balanced option was a diverse system with a vetch crop cut for hay into canola, then to wheat, then to barley. And we're able to retain the stubble through that whole 4-year sequence. So just an example of how introducing diversity into a full system and following it for 4 years, fully phased, shows that you do in the end come out on top. And often this is difficult for growers to see, because if you focus just on this year, the pulses will almost never be as profitable as canola, particularly if it's a wet year. If you focus on just the next year, 2 years, you often don't see these longer term effects on weeds, diseases, nitrogen and so forth. So you need to be at it for a while to fully see the benefits. And you need to keep checking that they're there. Here's a disease, crown rot, again, another disease that often will hang around for many years. You often need more than 1 year of break to get on top of this disease. This data shows the crown rot DNA tested in the soil. And I've just got a few different sequences. This is the canola wheat barley baseline, and what that's showing, we measured it in 2018 and then again in 2021, and we've actually had an increase in crown rot in that system. Where we had wheat canola system, we've decreased it, but not by very much, and we're still in the medium category. But a lentil canola wheat double break system has really gotten the crown rot down in 2 years to sort of into that low category. So again, some diseases are going to require more, a double break and more than just canola wheat to get on top of. So moving on to water now. Often grain legumes will use less water. They have slightly shallower root systems. Some of them are reasonably small plants. And often you'll find this is looking at how much water is left in the soil profile right down the depth. Wheat compared to chickpea and field pea, and you can see how the wheat's dried the system right out. The chickpea and field pea have left quite a bit of water in the profile, and in fact, looking at many, many years of data, often legumes will leave 20 to 40 millimetres of extra water, so you're often finding extra nitrogen with extra water, which is incredibly valuable, especially for a canola crop, to find that late in the season to build grain, and so that can be extremely beneficial. But there is a downside, that extra water that's left at harvest may not always be there when you come to sow the following crop, because you can see how much residue, how little residue is often left after a legume here, a canola here and wheat there. And looking at the end of the summer, quite often this benefit in water, by the time you get to the following sowing, has diminished because water's been evaporated from this lack of cover, and often maybe soil blown as well. And so So what I'm showing here is a whole lot of different experiments where we had different legumes growing and wheat. At the end of the season, lots more water left in all cases after the legume, but by the time we got to the following, to sow the following crop, those differences had diminished quite a bit. And in fact, in one situation, there was more water after the wheat than after the chickpea because of the cover that the wheat provided in the summer, capturing more water and storing it. So this is about fallow efficiency. And so you just have to balance these effects of the legume and try to ensure that you do have some resistant residue there, like wheat stubble, in your no-till systems to sort of make sure you're not leaving too bare a soil. And the impact on the following crop really depends a little bit on what happens in the following year in the rain, but you can see in some cases there will be a yield benefit going right through to the following wheat crop. In other dry years you may not see it. So the current project that we're working on has 4 sites in southern New South Wales. So that was sort of background from projects leading into this current project. This one started in 2017, and what we've tried to do is ask growers what they were doing in their system now and what are going to be their strategies to convert rainfall into profit across an entire crop sequence more efficiently whilst managing all these things I've just been describing. So in effect, we kind of put a lot of those learnings together into this project. We have all those partners I showed on the second slide, New South Wales DPI, and those are the 4 sites. So as you can imagine, I'm just going to show you some highlights. But the 3 things we were manipulating in this project were diversity, which is what today is about, nitrogen strategy, so, and I'll talk about the interaction of those 2 things. We also look at early sown graze crops, but I won't talk about those today. So we've got all of those, all interacting across time, fully phased, and we've got different sites ranging from about 400 mils growing season rainfall to about 250 from Greenthorpe down to Condobolin. And so, in essence, the system that I want to talk about today that we're comparing is this baseline system. All of the consultants and growers says, this is what we're doing now, this is what we want to be the baseline, we want you to compare things with this. And it's just timely sown, May sown crops, May sown crops, and we've got a nitrogen strategy that's decile 2. So I'll explain our nitrogen strategy. We measure the nitrogen before sowing, like a lot of growers do. When we get to top dressing in July, we assume that the year is going to be a decile 2, and we put on enough nitrogen to cover a decile 2 year. So it's a conservative, it's a grower who's conservative about nitrogen, and that's our baseline system. So we're comparing that with a more diverse system where we insert a legume in there instead of the second cereal, and we still keep that decile 2 nitrogen. So effectively, because we're measuring the nitrogen at sowing every year, if we get carryover nitrogen, either from a legume or from the fertiliser, we'll measure it the following year and we won't need to put on as much. So this is a dynamic nitrogen treatment that the sort of thing a grower might be doing in response to how much nitrogen is accumulating or disappearing, but always assuming a decile 2 season. And then we've got a more optimistic grower who always thinks it's going to finish as a decile 7, and therefore will be likely to be putting on more nitrogen, and again with the legume. And the legumes are, we have high value, high risk, like chickpea and lentil, more lower value, lower risk, lupin, faba bean, pea. This is risk to the grower I'm talking about. And then we've got the multiple end use things like vetch that can be cut for hay, brown manured, grazed, because we're in a mixed farming area. So those are the systems we've been comparing. And just the Reader's Digest summary, the most profitable thing over the first 3-year phase, we're sort of halfway through the second phase now, the most profitable thing at all sites was one of the diverse systems with the low nitrogen strategy. And it was $100 to $300 per year extra profit over and above the baseline. It wasn't always the same legume at every site, but it was always a diverse system that was the most profitable. And that came for 2 reasons. We had 2 howling droughts and then a very wet year, and right across those years there were legumes that were competitive in their profitability with wheat and canola. So it wasn't always that the legumes were dogs compared to wheat and canola. We had quite profitable legumes over the course of the 3 years. We can't always beat canola in the wet years. The best canola will often be the most profitable in that year, but remember we're looking at things over 3 years and phasing them. The second reason why the legumes were profitable is because they were giving this boost in nitrogen and in water in the dry seasons to the following crops, and we were picking that up in not having to apply so much nitrogen to following crops. And when we tried to match the legumes with the decile 7 nitrogen on the baseline, it wasn't more profitable and clearly more risky because we're spending a lot more money on nitrogen. So if you try and just work out what the value of that legume was in our system, growing a legume before the canola, there's 2 areas you can quantify: the savings in urea and the extra canola yield you got. So some of that extra canola yield might come from additional nitrogen, but remembering we're sort of trying to match the decile 2 and decile 7 nitrogen in all the systems. And basically with urea and canola prices as they were for most of this project, we were saving about 78 kilos of urea per hectare, which was valued at $47 then at those prices. We were getting about 0.2 of a tonne benefit in our extra canola yield, which at those canola prices was 143, so about $190 per hectare extra value from having the legume in the system. And if you start changing the price of either urea or canola, that value grows pretty significantly. And sort of currently that's where, you know, things are sitting more like those prices now than the prices we were experiencing in the last 3 to 4 years. So that's sort of one way we can see the value of this. And so certainly we're reducing our nitrogen costs. We also had reduced herbicide costs. In the diverse rotation, we ended up spending about $30 less per hectare per year on herbicides. And we had either stable or declining weed and disease levels, as I showed you before. So all of these things are adding up to a less risky and a more profitable sequence. And if we just look at the Wagga site, and again, here's our baseline N2 strategy. That's about the amount of urea we were putting on across those 3 years on average every year, and that was our profit, average annual profit over the full sequence. If we added more nitrogen, like you can see, we got a bit more profit, but we had to spend a hell of a lot of money to get it, and that probably wouldn't, you know, might be a risk a grower wouldn't take if presented with that information. Whereas our range of legumes at the decile 2 nitrogen strategy, you can see far less nitrogen required and increasing profits. And the legumes differed somewhat in their profit. The most profitable here in that sequence was the lupin, and it was about $100 a year more profitable per year over the full year sequence. And if we have a quick look now at what the implications of higher nitrogen prices have been. So here we've, and I haven't put the implications of higher canola prices here, but if we just look at the nitrogen, so we were running that experiment on that left-hand curve, you know, $500 a tonne for nitrogen, and that was our gross margin I just showed you. And I also showed you that at those prices, the N7, the decile 7 on the baseline was a little bit more profitable, not much, just a little bit more. You can see how that drops away very quickly as nitrogen prices go up, and very quickly it isn't profitable to be trying to prop up that baseline with higher and higher nitrogen levels. However, with the systems that included a legume, in this case lentil, and I said before lupins did better, you can see a much less impact on the bottom line of your entire sequence over the 3 years at higher nitrogen prices when there is a legume in the system. Not surprising, but some useful numbers, because although the principles don't change over time, the relativities of price and profit and risk do change, as do the agronomic challenges. So, and I won't spend a lot of time on this, but all of this information is being put into the farming system model AppSim so that we can ask the question, okay, well that's 3 years, but what does this look like over the long term if we take 50 years of weather data for these areas? And you can fiddle around with all sorts of parameters. And here I've just got 2 sites, Wagga and Condobolin, 3 of our systems, the canola wheat intensive, the canola wheat baseline, and the one in the middle is the chickpea canola wheat. And this is just the mean annual gross margin. And the green colour is just the nitrogen strategy. So I've been doing a 2 and a 7 experimentally. With the model, of course, we can do anything. So I've got a 5 and a 9 in there as well. But what you can see with the model is how risky are things, what's the variability around things, and as well as comparing over the long term, what do things look like. And you can see that legume system is more profitable and more profitable at lower nitrogen levels. You can also look at things like risk. So here I've plotted the mean annual gross margin against the mean annual gross margin in the worst 20% of years. So how do these systems go on average compared to the really bad years? And basically, you want to be up in your right-hand corner. You want to be making lots of money most of the time and still making it in the bad years. And the things that all sit up in that corner are these more diverse systems with a legume in the system. In this case, it's chickpea, mostly because our chickpea model has had the most testing. And you can also look at return on investment. And again, the things that are up in that right-hand corner producing a better marginal rate of return are these more diverse things. Just quickly, I was asked to sort of consider some environmental concerns, and here this is not my area of expertise, but I dived into the literature to see what I could pull out. And a few of the different concerns people have are things like nitrogen losses from the system. So this is a whole lot of N15 studies following an isotope of nitrogen to see how does nitrogen provided as legume residue compare with nitrogen provided as fertiliser. And the bottom line essentially is that there are slightly less losses from the system when you track the nitrogen. More is recovered in the soil basically from the legume residue, I think because it's going into the microbial biomass and staying there for longer and not being lost through different pathways. What about energy use? Well, the one comparison I could find, legume systems using legumes were using about half the energy of systems fertilised by crops. This is mostly because of the heavy energy used to produce nitrogen fertiliser. The CO2 emissions are interesting. There's more CO2 emissions. The biological nitrogen fixation process that goes on in a rhizobia is a very energy expensive process, biological process. But of course all the CO2 emitted is just being recycled because it's a plant. So it's getting it from the atmosphere in the first place. And so it's just essentially recycled CO2, whereas all the CO2 coming from fossil fuels to produce nitrogen fertiliser, is sourced from the burning of fossil fuels. So that's a net add to the environment. And nitrous oxide emissions far lower, a third from systems producing nitrogen by legumes compared to nitrogen fertiliser, because the risk of heavy use of nitrogen fertiliser is that NO2 loss. So all in all, and all the things Sadiq mentioned this morning about a high protein food source, food security, etc., and even the sorts of things that Western countries worry about in terms of ticking environmental boxes, there's a pretty good report card there for systems involving legumes. And so this is my last slide, and I think we've sort of done full circles, Steve, and back where we started. I mean, some of the barriers, I guess, if you think about canola and how it's taken off as a crop, one of the things about canola, it's just widely adapted to a range of soil types. So growers can be confident that they're going to get a reasonable yield, quite apart from the marketing, of course. I've got to say that, when you talk to growers, and I'm not going to try and say too much because you're going to hear from growers, but we do get disease epidemics come through. They're heartbreaking crops sometimes to grow, either because prices drop or because you get a wet season and your yield's looking good and then you're out spraying fungicides time and time again. And just to give you an example, our chickpea crop last year, Tony put this together, it got early ascochyta, then it got whacked with low temperatures and knocked all the flowers off in September, then it lodged, then we got sclerotinia, ascochyta and botrytis, and we sprayed it 10 times. So the farmer we were working with had really picked up on chickpeas. He'd been watching us and started to put it in a few paddocks. He missed one of those sprays, just one of them, and Tony went out and did ours, and we got 3 or 4 tonnes, I think, of chickpeas, so we did all right, but he missed one spray and lost half his yield. So they're really challenging under those circumstances. And so, there's breeding, I guess there's breeding opportunities, there's other opportunities to try and deal with that. But of course, I guess we've already talked about the marketing and the price volatility. So we'll hear from the experts, so I won't say any more about what the barriers are. But being pretty agnostic about legumes and coming into this project, I think you can see that the agronomic benefits and the system benefits and the environmental benefits are there. If we can crack some of these barriers, then I think there's some real wins. Thank you.
Just a question from the ether, from Jens. Based on this data, a good legume option for the higher rainfall zone could have even more impact given how much nitrogen those growers have to add. So I guess that's a statement, but would you like to comment?
Absolutely, absolutely true. And when you actually look at nitrogen responses, nitrogen fertiliser responses in crops in the high rainfall zone where they're getting 4, 5, 6 higher tonnes, they never really get responses to nitrogen above about, I don't know, about 250 kilos of N. Like if you keep adding nitrogen fertiliser, you don't see much response, although you're pulling off 9 tonne, 10 tonne crops. That's all coming from the soil mineral nitrogen. So to underpin those really high yielding crops in the high rainfall zone, there's a lot of nitrogen mining of the soil organic matter going on. So they are going to have, and as I said, a lot of people are using granddad's nitrogen that came from the pastures they had many years ago, but that's running down, and they're going to need a good legume in the system to support those sorts of off-takes.
Hi John, did your research look into grain quality in those rotations? So whether or not the legume system actually provided better grain quality in your wheat and barley rotations following compared to your synthetic fertilisers?
We have done protein. Tony, are you alert? We saw some awfully low proteins in our low nitrogen strategy in the wet years, I'm talking 8%, 7%. We saw that lift with higher fertiliser, but we certainly saw it lift with legumes in the system. Would that be a fair assessment? So yeah, we have got all that data, and yes, you certainly see that lift.
Yeah, excellent presentation. Thanks for that. I'm Nanthi Bolan from University of Western Australia. One of the major benefit of legume is in relation to nitrogen fixation, and environmentally, nitrous oxide could be a bigger issue, but economically, ammonia volatilization is a bigger issue. Has anybody compared the ammonia volatilization between legumes and fertilizer nitrogen?
I probably won't try and answer that myself. I'm sure somebody has. And Mark Peoples, I can probably take that question on notice, unless someone in the audience has done that sort of work.
Fertilization losses much from the bag nitrogen than the legume nitrogen.
Is it more or as much? More,
Less
yeah.
From the legume nitrogen.
Yes, yeah. That's what I would have guessed. I mean, I think ammonium volatilisation is worse in warm conditions when you put urea on alkaline soils, and you've got warm, moist conditions. I think that's when a lot of it happens. I'm not so sure about legume residues, but my guess would be it would be much worse when you're putting a really concentrated form of urea on the soil surface, as many people do with fertiliser nitrogen. If you're using a different form or injecting or something like that, you can probably reduce it.
Question here, Mandy. Go ahead.
So actually, the thing is, when you're growing lupins or chickpeas, you normally, you inoculate with rhizobium. And I just wonder, if you just keep growing the thing without, inoculate with the rhizobium, the nitrogen will be lost or reduced capacity, to produce nitrogen for the plants or something like that?
Yes, yeah. I mean, if you've got very high mineral nitrogen in the soil, certain legumes, particularly I think chickpeas, really don't like that. They really won't fix much nitrogen if you've already got high mineral nitrogen sitting in the soil. So, this is where the systems thinking comes into it. Like, you really want to put your legume in there when it's going to do the best work for you. And so that would be when you're low in nitrogen, when you're high in weeds, when you're about to sow a crop like canola that needs a lot of nitrogen. There's places there's triggers to say, in my system, in terms of profit, this is providing, I guess you've got a market and you can sell the stuff. But there are places to put it in your system where you're really going to get a lot more bang for your buck, and it's not going to be lazy and essentially just use the nitrogen that's already there. And you might as well have canola in there doing that if that's what you want.
We've got 3 more questions. One there, one here.
Yeah, hi John. I was just wondering, given the problems with marketability of legumes in Western Australia, do you think it would be as effective to use a legume crop, especially in the medium and higher rainfall zones, as a fallow replacement? And would you get those same benefits going, say, summer cover crop into canola and then back into your rotation as you would as putting in a grain legume into canola and then into your regular rotation?
Yeah, so we've got a lot of guys in our area doing brown manure vetch, and I've seen the sort of economics of it. If you just say, oh, brown manure vetch versus I could have had canola there, what a stupid idea. Doesn't look very sensible in that year. But if you look at it over the whole farm and you look at it over 3 or 4 years, a lot of the consultants show that it actually does pay, partly because if you're not having to worry about that quarter, I think they do it on a sort of 25% of their farm. If you're not having to worry about trying to manage that right through to harvest and you're taking it out, spraying it out, whatever, then you can be much more timely with the rest of your farm. You can do that a lot better. That looks after itself. It sets you up then for a really low risk canola crop because you've got water, you've got weeds, you've got on top of the weeds, you've got on top of the water, you've got nitrogen, so bang your canola crop there. And when you look at it over space and over time, it looks a lot more economically sensible than just like, oh, well, that's a waste of money. I could have had a wheat crop there. But you'd have to do, it's all very business specific. You'd have to look at your business and see whether it paid. But yeah, it's not as silly as it sounds.
Thanks, John. It's good to see that you are now coming to legumes. You're a canola man, and once you never believed in legumes, it's really good. My question or comment is that when you have 2 or 3 species of legumes, they're not all adapted to the soil type. And perhaps that's the reason why at Wagga your lupin shot up. So that's an answer to that. Yeah. The second short question is that I thought the chickpea should be extracting more moisture from deeper layers because of its phenology and the way it uses water later on at the high temperature. I can see with the lentils, there's a lot of evidence from ICARA and other places that lentil always leave water, and that water may be useful if it is in the deeper layer for a dry year, for example, when you have a dry year. So 2 comments. One is the 3-4 species at one location. So one will be advantages. The second one is why the chickpea use less water. Yeah, so on your first point, yeah, we've got mostly loams and sort of duplex clays, and they're mostly acid. So all of the grain legumes, apart from faba beans and lupins, struggle a bit with that. But we limed all of these sites, we limed them all to pHs that we knew we could grow all these crops reasonably well, or we thought we could. We've got a lot of subsurface acidity that's very persistent because of the no-till, the lime going on the surface. We've just got this layer. We really had to get the lime in, but we were determined that we were going to grow these pulses to their best to see what they could really do, because there was no point if you're not going to lime and you put a pulse in. Well, you're not really giving it a fair crack. But yes, and certainly, as I said, the best pulse wasn't the same pulse in all of our 4 sites. Having said that, we've pretty much fallen back onto faba beans and chickpeas. The lentils have been very difficult, but the chickpea, lupin is already grown in southern New South Wales, and if its price were higher, people would be growing it again for sure. But in terms of the slightly more profitable or human food ones, the chickpeas, we've settled on chickpeas in the second phase and fabas for the wetter sites. And on the water, yeah, that data, a lot of that data on chickpea was from Lindsay Bell, a bit further north than me, on the deeper clay soils. Tony, have you got a comment on that? Because chickpeas certainly will stay green and keep sucking water out for longer, but we often see a little bit more water left after chickpeas than wheat and canola in our system.
Jeremy Wishes asked me the same question, and it's exactly why we're doing a rooting depth experiment on chickpea this year, because in our, go back to 2019, we had set up a beautiful experiment just looking at chickpea and lentil, and with neutron probes, having a look at the extraction level of where we were removing moisture from. And, you know, they really were not taking moisture out, say, below 120, 140, you know, and generally it was above. And we couldn't find many roots below that. And Jeremy just said, who comes from, you know, a vertisol in Toowoomba, just said, they should be just keeping on growing. So there must be some constraint. We're going, we don't know what the constraint is. Everyone else, every other crop generally can get through there. We understand in the lentils, like there's no acidicity, there's no salinity, there's no, you know, it's a beautiful, most of these sites are beautiful soils, but they're just not getting their roots down. So it is something we're looking at this year, and yeah, we're actually doing a root experiment specifically on that.
Final question. Ken Flower from UWA. Very interesting. I was just had a question with regards the weed control in the legumes, and I was interested to see they had lower costs there. And also you mentioned that putting legumes into where you've got high weeds, the implication being to control them. I think in a WA context, often there's actually sometimes more herbicide used on some of the legumes, particularly on the lupins, and the weed control is very iffy. So I wonder if you've got any comments on that, because weeds are considered a weakness here.
Yeah, no, I'll let Tony, in fact, Tony started to talk to me about that last night, but there's been a bit of a change, you said, Tony, recently in the herbicides that you can use on grain legumes. It's been quite important, but I'll let Tony, he's the weed expert.
Yeah, go Ken. Depends on what experiments. Some of the earlier data John was presenting was from, say, 2012 to 2017. Compared to now, you know, there are certainly different herbicides out. You know, we've now got, you know, Reflex out, which it takes out, you know, we can spray on most of our pulse crops and takes out most broadleaf weeds, very, you know, quite cost effectively. We're in a different environment too, because we are aiming for, we're more medium to high rainfall, so we are aiming for higher yields. If we were only talking about, you know, a tonne per hectare of chickpea, or, you know, a tonne and a half of lupin, you know, you're starting to look at different economics and different herbicides. But yeah, but there are some new technologies, new herbicides out, which are certainly fantastic for both grasses and for broadleafs. And the broadleafs have been much harder to control in our system than the grasses, to be honest with you. And I suppose, just going back, we're always looking at a double break. No matter what happens, we just look at it 3 years to try and reduce ryegrass, and then it's out of our system. And whereas you guys over here are doing similar stuff, but you're also looking at, you know, at mechanical, you know, weed seed destructors and everything else as well, which are coming over our way.